Imagine a time in the universe's infancy known as the Dark Ages, a period so mysterious it's like a cosmic curtain draped over the early cosmos. This was an era when galaxies shouldn't have existed. At least, that's what our understanding of physics and cosmology has long suggested. According to our theories, it was far too soon after the Big Bang for matter to have clumped together into anything substantial. And yet, the James Webb Space Telescope has shattered this idea, revealing massive galaxies from this so-called dark age. How is this possible? This discovery has thrown our entire narrative of the universe's formation into chaos. How could these galaxies have grown to such colossal proportions in such a short time? Did they form differently than the galaxies we see today? Could some unknown process have accelerated their growth? Or, more shockingly, could the universe have evolved in a way we've never even imagined? I am Bob, and you are watching Space Theory. Don't forget to like, subscribe, and press the bell icon so that you don't miss any upcoming videos. Since it first started peering into the void, the James Webb Space Telescope has been pushing the limits of what we can observe in the universe. Recently, it made a groundbreaking observation. 6 enormous galaxies formed just 500 to 700 million years after the Big Bang. This discovery is extraordinary because, at that point in cosmic history, the universe was just a baby, barely 3% of its current age. Scientists expected to find small, irregularly shaped galaxies, mere cosmic embryos still in the throes of development. Instead, Webb has uncovered gigantic, mature galaxies that defy all logic. How could they have grown to such proportions in such a short time? The enormity of these galaxies isn't just surprising, it's almost unsettling. One of these celestial giants may possess a mass up to 100 billion times that of our Sun. To put that into perspective, our own Milky Way, an ancient and well-established galaxy, contains a stellar mass equivalent to about 60 billion suns. The combined mass of stars in these early galaxies is several billion times greater than what scientists expected to find in such a young universe. This raises a slew of questions. Did galaxies in the early universe form differently than those we see today? Did some unknown process accelerate their growth? Or is there something fundamentally wrong with our understanding of cosmic evolution? In an effort to get to the bottom of this mystery, researchers ran advanced computer simulations to model the formation and evolution of the first galaxies. What they found was startling. Unlike the gradual star formation we see in the vast galaxies that populate the modern universe, the early galaxies appeared to form their stars in sudden, massive bursts. This means that astronomers' traditional method of estimating a galaxy's mass, based on its brightness, might not apply to these early cosmic giants. They were expecting small, newly formed galaxies, not these colossal structures that seem to have sprung into existence almost fully formed. The Webb telescope made these discoveries using its infrared sensors, which are capable of peering into regions of space that have been obscured until now. These galaxies were located in a little-known part of the sky, hiding in plain sight. What's even more astonishing is that 2 of these galaxies had been spotted by the Hubble Space Telescope years earlier, but they appeared so faint that they were essentially overlooked. Thanks to Webb's enhanced capabilities, we now know that these faint spots are actually massive, mature galaxies, raising profound questions about how they came to be. So, what could explain the existence of these enormous galaxies in a universe that was supposed to be just starting to find its form? One possibility is the role of dark matter, the mysterious and invisible substance that makes up most of the universe's mass. Scientists think that dark matter clumps together into halos, drawing in gas from the surrounding universe and eventually forming galaxies. However, this process was thought to be relatively slow, especially in the early universe when dark matter clumps were scarce. If these massive galaxies were indeed formed by the gravitational pull of dark matter, it would mean that this process happened far more quickly and efficiently than our current models predict. Adding another layer to the puzzle, these galaxies are populated with stars that are old and red, indicating maturity. This is in stark contrast to earlier observations of young, blue stars typically found in the early stages of galaxy formation. How could stars have aged so rapidly, and why do these galaxies seem to resemble mature ones like our Milky Way, rather than the chaotic, star-forming nurseries we expected? The James Webb Space Telescope is, quite literally, changing the way we understand the universe. When scientists first saw these universe breakers, they were stunned. It was as if the history books of cosmology had been thrown into the air, scattering pages everywhere. These findings suggest that the universe may have had a much more dynamic and rapid period of evolution shortly after the Big Bang than we ever anticipated. And the implications are staggering. Could we have missed something fundamental about how galaxies form? Could there be unknown processes at play that we've never even considered? Webb's ability to observe infrared light is key to unraveling this cosmic mystery. You see, as light travels across the expanding universe, its wavelengths stretch, shifting toward the red end of the spectrum, a phenomenon known as redshift. By measuring this redshift, astronomers can calculate how far back in time they're looking. The galaxies Webb is observing existed within just a few 100 million years of the Big Bang. But what Webb is finding goes beyond just locating these galaxies. It's also revealing their internal structures and activities. This is where spectroscopy comes into play. By splitting incoming light into its component colors, Webb can identify the chemical composition and activity within these galaxies. Each color in the spectrum corresponds to specific interactions between photons and atoms, providing clues about the processes occurring inside. For instance, a hydrogen atom flashing as it settles after a shock might emit one color, while jostled oxygen atoms emit another. It's like having a cosmic X-ray machine that lets us peer into the heart of these ancient galaxies, revealing what they're made of and what's happening within them. Could this new information indicate that the universe expanded much more rapidly than we thought, allowing stars to form in concentrated bursts? This ties into ongoing debates about the universe's expansion rate, which some scientists believe is faster than previously calculated. If true, it could mean that we're on the brink of a major revision to our understanding of cosmology. But there's more. Webb's observations could also shed light on the role of supermassive black holes in galaxy formation. Hidden within these ancient galaxies might be some of the earliest black holes, whose gravity could have helped draw in matter, accelerating star formation. By analyzing the light spectrum emitted from these galaxies, scientists hope to detect the telltale signs of these massive, mysterious objects. In essence, Webb is offering us a time machine that takes us back 13.5 billion years to the universe's infancy, revealing a reality that challenges every assumption we've held about how galaxies form and evolve. The discovery of these colossal, mature galaxies suggests that our universe may have a far more complex and dynamic history than we've ever imagined. What we're witnessing is the unfolding of a cosmic drama that could rewrite the very foundation of astronomy and physics. Could the universe have evolved differently than we thought? Are there unknown forces or elements that accelerated the formation of these galaxies? With every new observation, Webb is sending ripples through the scientific community, sparking debates, and pushing us to reconsider long-held beliefs. This is only the beginning. The James Webb Space Telescope continues to scan the universe, and with each new image, it brings more questions to light. As we stand on the cusp of potentially rewriting the history of the cosmos, one thing is certain. The universe is far more mysterious and wondrous than we ever dared to imagine. If you're as fascinated as we are by these revelations, don't forget to hit the like button and subscribe. The cosmos has many more secrets to reveal, and we'll be here to explore them with you. Until next time, keep your eyes on the stars, because the universe is only just beginning to tell its story.